Oh my goodness, listen to this. This is amazing music. Logarithms. Logarithms. I hope you get it. There's a joke in there somewhere. All right, so we're going to be learning about logarithms today, spelled a little differently, but we're going to derive some properties. We're going to expand them, which means make them bigger, right? And then we're going to condense them, even though it doesn't say condense, but that's what we're going to do next. We're going to start on page 643. Stay with me here. Pause the video if you need to. We're going to move as quickly as possible, but not any quicker. Let's look at the property of powers associated with each example. So here we see that 2 to the 5th times 2 squared equals 2 to the 7th. Or another way to think about this is we have 5 2's and then 2 more 2's, and if we're multiplying them all together, that's going to give us 7 2's. That's not a difficult concept, right? But that's one of those exponent rules that a lot of students have forgotten. It's called the product rule of powers. Now, number 2, what's any base to the first power? Well, any base to the first power equals itself. So that's a rule that we need to know. What about any base to the 0 power? Well, any base to the 0 power equals 1. Now, that's called the 0 power rule. Some of you think it equals 0, and so you better watch out. It equals 1. Anything to the 0 power equals 1. And then lastly, when we have a quotient, think of it as like, it's kind of the opposite of a product. Product means multiply, right? We're multiplying here. Quotient means divide. So we're going to do the opposite. Up here, we added the exponents. Down here, we will subtract them. 14 minus 5 is 9. That's called the quotient rule of powers. So we have to know the names for, when we justify our steps. Let's move to the next page, which is 644. We're going to review all of these different powers. Now, the product rule of powers we just looked at the page before. The power to a power rule, let's check that one out. What if we have like 2 to the 4th power, and that's raised up to the 3rd power? By the way, let's do that over here with the no, I don't want to get crazy. I'll go back and do that in a second. But 2 to the 4th power raised to the 3rd, that equals 2 to the 12th power. That is called the power to a higher power rule. Now let me show you why up here really quick. 2 to the 4th to the 3rd. That means we have 2 to the 4th times 2 to the 4th times 2 to the 4th, which means, that's 4. We have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. If you count them all up, there's going to be 12 total. There's 3 4s. Okay, so that is the power to a power rule. Let's go back and give an example of the product rule of powers, which we did in the other example. But what if we had 2 to the 4th times 2 to the 3rd? That means we have 4 2's and we have 3 2's. We could write it all out. That'll be 7 2's. So we add them. The quotient rule. Suppose we have 2 to the, we'll say 12th. And then down here we have 2 to the 5th. What will that equal? The quotient rule, we are dividing. That's what quotient means. So we would have 12 2's on top. We take 5 away. 5 would cancel. So it's simple subtraction. That would give us 2 to the 7th. The rule is subtract there. Now, the 0 power rule, we know what that means. Anything to the 0 power equals 1. And then the negative exponent rule. Let's do 2 to the negative 3rd power. This one has been difficult for a lot of you to remember. A negative exponent means you can do 1 over that positive exponent if you change it from negative to positive. Another way of thinking about this is you can go from the bottom of a fraction to the top if you change the sign of the exponent. So if it goes here, it's negative on top, you can put it in the bottom and make it positive. However, if it was if it was negative in the bottom like this is the same as, we can bring that up top and make it positive. So that would just be 2 to the 3rd. That is a little different there, but that's the negative exponent rule. So we were supposed to learn this in previous courses. So you're supposed to be good at that. If you need help, please reach out. We can get you some extra practice. We're going to start with number 1, though, using the product rule of powers. I gave you the property first, and then we're going to go back and use it. The product rule of powers means that when we are multiplying 2 common bases, we can add the exponents. And when I look at A here, we're going to treat coefficients as regular old numbers here. We have 4 times x to the 5th times 6x squared y to the 6th times x times y. The first thing I'm going to do is deal with these regular old numbers. All right, so it's just 4 times 6. That's 24. Easy enough. Now I'm going to deal with all of the x's. Okay, so we have 5 x's here. We have 2 x's here. We have 1 x here. The product rule of powers says that we can add those exponents. So we're going to have 5 plus 2 plus 1 more here. You can write the 1 if it helps you out. but that's going to be 8 total x's. And then lastly, we're going to look at the y's. We have how many y's? 6 y's, and then one more y right here. That's 7 y's. So the final answer here is 24 x to the 8th, y to the 7th. And again, we're using the product rule of powers. All right, let's do number 2. By number 2, I mean letter B here. We're on 644 still. What am I going to do with this one? Well, let's put this all over 1. We'll kind of look at it that way. And I'm going to multiply the tops. So the 42 I'm just going to leave. Let's just leave that 42. And then I'm going to say we have m to the 5th times m to the 4th. That's going to be m to the 9th because we're adding those exponents, the m and the m. Then we can look at the n's. We have n to the 3rd and n squared. That's going to give us n to the 5th. And that's all going to be over. Now I'm going to do the denominators here. 1 times 6, that's 6. We have m to the 6th, that's it, and n to the 5th. Okay, so now what are we going to do? Well, what I would do is I would start subtracting these. Look, we can use the quotient rule now. So let's just divide the regular numbers, just like their coefficients. They're just like a regular fraction here. 42 divided by 6, that is 7. And now we take the exponents and we can subtract them. 6 of these m's will cancel 6 on top, and that will leave 3 of them. And for the n's, it's 5 minus 5, which is 0. But I'm going to write that out. You don't have to write that out because they cancel and leave a 1, right? So that's going to be our final answer. 7m to the 3rd. N to the 0 just equals 1. So this is going to be our final answer. So all that whole blob there reduced to this. But we were supposed to justify. How come we're not justifying here? Let's justify. The first thing we did is we used the product rule of powers. And then we used the quotient rule by actually taking these and subtracting. That gave us this answer right here. And then we used that n to the 0 power is just 1. So I didn't need to write it. That's the 0 power rule. All right, now you try to do C all by yourself. Pause the video and try C and then come back. There's a trick with C and it involves that negative. So good luck to you. Give it a try. All right, let's see if you did C correctly. By the way, I'm going to rewrite C because there's no exponent on here. And we have to use our parentheses as our friends. So check this out. We have a -3. And that doesn't have an exponent on it. So I'm going to put a 1 up there. And as you can see, I put parentheses around the -3, and that's kind of important. Remember, we always talking about our parentheses here. Otherwise, what you're going to do is put the exponent on the 3 and then make it negative. And that's not what we want. This is a -3. So we're going to do -3 to the 1st power, and then x to the 7th and y to the 3rd. It looks exactly the same, but I just put parentheses around that -3. So now what? Let's use our powers to powers rule. Okay, I can multiply that up. So this is the same as we have -3, and then we do 1 times 5. That's 5. And then we have x to the 7 times 5. So that'd be x to the 35. And then y to the 15 using the same rule. Now I just have to figure out what -3 to the 5th power is. This will end up being negative. I get -243, and we can write it as x to the 35th and then y to the 15th. Now, what product did we use, or what property did we use? Pretty much the same one for most of this. This is the power to a power rule. Woo, almost confused myself on that one. Now let's look at the properties of logarithms. Let's consider how logarithmic rules and properties correspond to the exponent rules that we already know. So we've reviewed all of that. We're on page 645. We're going to write a sentence to summarize the 0 property of powers. B to the 0 equals 1. So let's summarize that. What exactly does that mean? Well, as we said, any base raised to the 0 power equals 1. That is the 0 property of powers. Now, it wants you to write it in logarithmic form. So whenever they ask me to do that, I got to write it out. I got to write it out in exponential form. They did it right here for us, but I'm going to rewrite it. The 0 property of powers means that the base to 0 power equals 1. That's always true. So if I wanted to write this in logarithmic form, which we just had a test on this, didn't we? We just did. The base is b. So I would say log with a base of b, all right? And then it always equals the exponent, and then right here is called the argument. That's 1. So log base b of 1 equals 0. That's easy enough. And if I wanted to write that out in words, the logarithm of 1 with any base is always equal to 0. So log of any base of 1 is always going to equal 0. Okay, let's go down to 2. Still on 645. Let's consider the base raised to a power of 1 rule that says that any number raised to the power of 1 is equal to the base. Let's write the exponential equation for that. Okay, I can do that. Let me get my little cursor going here. So I like to write exponential, right? So what does that mean? You have some base and you raise it to the first power. It's always going to equal the base, right? So now let's write that in logarithmic form. So b to the first power always equals b. So if I write it in logarithmic form here, we have log, what's the base? B. Okay. What's the exponent? 1. So I always set it equal to 1. And then the argument here is b. So log base b of b equals 1. That is our logarithmic form of the exponential equation, which is basically the base raised to the power of 1 rule. All right, so saying this relationship in words, when the base and argument are equal, then the logarithm will always equal 1. I guess I could say always in here. We want to say always. It always equals 1 if the base and the argument are the same. Easy enough. Here's how I would word it. When multiplying terms with a common base, right? They're both the same base, and you're multiplying them, then you add the exponents. So now what we're going to do in B is we're going to derive a corresponding logarithmic property. We already know that b to the m times b to the n equals b to the m plus n, right? If I have to use regular numbers, we did that earlier, so 2 to the third, 2 to the fourth, that equals 2 to the seventh, right? So if I generalize it and I take the numbers out and I just put some variables in for each number, then I get this general equation here. Now, let me show you what we're going to do. We're going to do a little trick here. First thing we're going to do, I'm going to circle the first term, and I'm just going to call that x, okay? And then I'm going to circle the second term, b to the n, and I'm going to call that y. So we get x times y equals b to the m plus n, okay? I'm just going to call this first one x, and I'll call the second one y. By the way, that's where this comes from. So we're going to look at this here in a few minutes. But look, it says xy equals b to the m plus n. We got that by just naming b to the m x and b to the n y. Now I'm going to take each x and y and I'm going to rewrite it in logarithmic form here. So this means that log, what do we got here? If we let x equals b to the m, which is what we started with here, I'm going to write that in logarithmic form as log base b. It's always equal to the exponent, so it equals m. It's of x. So log base b of x equals m. That is taking this equation and just rewriting it in logarithmic form. And if I do the same thing to y, then it's log base b of y equals n. And that's where this equation comes from. All right, we're about halfway done. Stay with me. Maybe you need to back it up. Listen to everything again. Make sure you're following me. All right. So if you remember, we had this equation. We're going to work with this right now. What are we going to do here? Well, I'm going to write this in logarithmic form, okay? So the base is b, so it's log base b, and it always equals the exponent, so that equals the exponent we have here, m plus n. So it's log base b of x, y equals m plus n. And you know what? We're almost done. We got one more step. The last step is I'm going to take out that m, and I'm going to put in what m is equal to. Remember what we said m is equal to? We wrote it in logarithmic form. It's equal to log base b of x. So I'll write that down. Log base b of x. And then I'm going to take out the n, and I'm going to put what n is equal to. This is substitution. N is equal to log base b of y. And it was m plus n. Plus. And remember, this came from this equation. We wrote it in logarithmic form. It was m plus n. And where did that come from? That came from the fact that we add exponents. Where did that come from? Well, remember up here, if we have 3 and then we have 4, adding them together is the total number of bases. So rewriting in logarithmic form, substituting in. Here's the final rule. By the way, this is the final rule. Let's put a smiley face by it because it's important, of course. Log base b of x times y equals the log base b of x plus the log base b of y. In other words, it says state it using your own words. In other words, this is a rule we're going to use. What is the rule? The logarithm of a product, so if you take the log of a product, the log of xy in this case, is equal to the sum of the logarithms of each factor. Okay, so each one of these is a factor. So I can take the log of each and add them together, or I can take the log of their product. Okay, guess what? That's the same as up here when we're multiplying. The rule for exponents is add. So when we're multiplying, the rule for logarithms is add. Ta-da! It's the same rule because a logarithm is an exponent. Oh my goodness, let's do another one. We're now looking at the quotient rule of powers, which let me get my cursor up here again. Let's use a real example here. So if we have like 2 to the 12th and we're dividing it by 2 to the 5th, really, I mean, what do we do? That means we have 12 twos. I mean, I could write them all out, but you'd have like a whole bunch of twos, 2, 2, 2, 2, 2, 2, 2. And then on the bottom, you'd have 5, and they would cancel. This would all equal 2 to the 7th, right? So that you subtract. The rule is subtract. So when dividing powers of the same base, gotta have the same base, then you can subtract exponents. We are going to play the same game that we just played with the other one. Now, if you're a boss, if you're an OG, you can pause this right now and you can try to do it all by yourself, okay? But it's not necessary. This is a little bit tricky, so I will lead you through it. But if you want to try, go ahead and then you can unpause it and see if you get it right. Here we go. We're going to start in a similar way here. We have b to the m divided by b to the n, and that equals b to the m minus n. And we do have to put b can't equal 0 here because you can't have a 0 in the denominator. We already know that. Can't divide by 0. So we're going to start this one very much like we started the other one. We're going to take the numerator and we're going to let that equal x. We're going to put an x in the top and we're going to put a y in the bottom. And so we're going to let x equal b to the m and y equal b to the n. That means that if I use substitution here, x divided by y, I'm just going to substitute, right? Because I'm calling this x and I'm calling this y. That will equal b to the m minus n. Fantastic. Now, rewriting them as logs right here. So the base is b and the exponent's m. So log base b of x equals m. Okay, that's just writing it in logarithmic form. Oh, that is probably not a good sign. I was going to put a little check mark. Same thing for y. Y equals b to the n. So log base b, and it equals, the exponent always equals n. So now we have these two equations that we've set up where we have m and n equal to each one of those. But I'm going to substitute right now. What is m and what is n equal to? Well, let's rewrite this in logarithmic form first. So the base is b. So we're going to have log base b. Okay, what's the exponent here? M minus n. Okay, that's the exponent. And then the argument would be x over y. See how this is very similar to the other one? And now finally we're going to use substitution. Forgot my equal sign. We're going to take the m. We're going to plug in what it's equal to. We're going to take the n and plug in what it's equal to. So log base b of x over y equals m, which I have over here. So I'm going to write it as log base b of x minus, and now I write n. N is log base b of y. Log base b of y. So what did we conclude here? If I take the log of a quotient, it's equal to the difference of each individual log. I can take the log of the first one and subtract the log of the second one. How am I going to write that out in words? Here's what I came up with. The logarithm of a quotient, means divide, right, is equal to the difference of the logarithms, or put a plural there, of the dividend and divisor. By the way, those are the fancy words for, what you start with and what you divide by. Right? Easy enough. Oh my goodness. Now to page 648, here's the thing. We've done 2 of these. You can look through this last one. You can pause it and copy it down. To simplify a power to a power, keep the base and multiply the exponents. That's what the rule is. So what does that mean for logarithms? We're just going to jump to this last part here, but you can look at what they did. It's a very similar proof. It's b to the m to the n. You take b to the m, you make it x, and then x equals here. Rewrite it as a log. So then we have x to the n equals b to the mn. And then again, you write that as a log. And what ends up happening is that exponent comes down front. So this one, this is actually, you can start, this is what I care about. This part right here and this last part. If you don't write the middle part down, I guess that's okay. But you do need to know this rule here. If you take the log of a base and that's raised to a power, that power can come down front. So it is equal to n times log base b of x. Okay, and I'll show you how this works with real numbers here in a second. But in words, the logarithm of a power is equal to the product of the exponent and the logarithm of the base. All right, let's actually take a look. So here's an example I just made up. Log base 2 of x to the 5th power. If we have that, our rule for our logarithms is you can take, the base is 2, you can take that exponent, which is on the argument here of x, and you can take that and bring it down front. That's basically what this rule says right here. So this would equal 5 times the log base 2 of x. And see how that 5 can come down front. So we are now going to use all of our properties to simplify, expand, and condense. On page 649, they want us to use the properties of logarithms to rewrite each logarithmic expression in expanded form. In your head, you just have to remember expanded means make it bigger and spread it out, which means you're going to go from multiplying into adding. You're going to have one log into many. So let's use our product rule for logarithms right here. There's a product between 6 and x to the 5th. We have two different factors here. So our product rule says that that the log of a product is equal to the sum of the logs of each factor. What? That means basically we can split them up and put a plus in the middle. That's the simple version. But we have one more step as well. That last rule we learned, the exponent can come down front. So the final answer for this is going to be log base 4 of 6 plus 5 times the log base 4 of x. And that is going to be our expanded form. We had 2 steps we had to do. Oh, that is ugly. The first 2 steps, we split it up and then we add, and then that exponent comes down front. All right, that's how you do 1a. How's it going to be? This is a quotient. It's the opposite of a product. So we're going to do the opposite of add. We're going to subtract. So this is all going to equal the log base 7 of whatever we have on top. All right, so that is 3y to the 4th. And we're dividing by, or we're subtracting, it's going to be the same log, use the same base of what we have on the bottom. Now, as I do this, look what I notice. There's a product here. We have a 3 and we have a y to the 4th. So I'm going to break this log up. So log base 7 of 3 plus log base 7 of y to the 4th. And then we're going to subtract our log base 7 of x to the 3rd. We have one more step. We're going to bring both of those exponents down in front. Now, that exponent, that 4, only goes on the y. If there were parentheses, we'd have a different situation. But there are not. That 4 only goes to the y, which means I bring that 4 down only in front of this log. Our final answer is going to be log base 7 of 3 plus 4 times the log base 7 of y minus, oh, we got to bring that 3 down too, 3 times the log base 7 of x. This is expanded, isn't it? We took one log. Okay, one log. We took one log and we made 1, 2, 3 different logs with it, and we pulled all those exponents down. That is how you do the first part where we have to expand. Okay, that's expanded form. We are expanding. Now, we're going to work backwards. It's the same, everybody. It's the same, but backwards. We're going to look at what we would have as the solution to number 1, and we're going to condense it. It's called condensing, but the directions here say write it as a single logarithm. So you can only write log one time. So what do we have right here? This is log base 2. All right, what do we have? We have that 3 that I see is in front, so that's going to come up on the x. So it's going to be x to the 3rd, and we have addition, which means we're multiplying. Should be a product, right? So we're going to do, this is log base 2 of 10, and then the product means we multiply. There's an x here, and that 3 goes up, but just on the x. That's how you do 2a. We've made one log. We're basically done. We're done with that one. Let's try the next one. We know this 4 can go up onto the 12, and this 4 can go up onto the 2. So this is going to equal log of, remember we can only write one log. So it's going to be the log of 12 to the 4th. And we're subtracting logs. That means we have to divide. And this is going to be 2 to the 4th. And I'm just going to leave it like that. Could you figure that out and get a number? Yeah, of course you could. But we're practicing our logs. We're not doing that. Okay, and our last part, let's look at 3a. We'll do 3a and 3b. Suppose that log base a of 5 is p, log base a of 3 is 5 is q, and log base a of 2 is r. Write an algebraic expression for each logarithmic expression. So here's what they want you to do. They want you to look at 50 and break it up into 5s, 3s, and 2s. And then after you do that, then you can write several logs that will represent log base a of 50. So I'll show you what I see right here. I know that 50 is 2 times 5 squared, right? So 50 is 2 times 25, and that's 5 squared. So log base a of 2 times 5 squared, I can just break that up into log base a of 2. Now remember our rules. We're multiplying, product rule here, so we're going to add logs. Log base a of 5 squared, but I'm going to bring that exponent down and call it right here. Now look, use a different color. Log base a of 2. What's that equal to? They told us right here. Log base a of 2 equals r. So that's r plus 2 times, what's log base a of 5? They told us that's equal to p. So this one becomes r plus 2p. What? That's all they want you to do. So let's look at b. B is a little tricky here. We have log base a of 0.3. Well, I know that 0.3 is log base a of 3/10. And 3/10 can be written as 3 over 2 times 5, 3 over 10, right? That's what 0.3 is. 0.3 equals 3 over 10. How do I get a 10? 2 times 5. So I can rewrite this as log base a of 3, and I'm dividing by both of these, the 2 and the 5, so I'm going to subtract both of them. Log base a of 2, and I'm going to subtract, as I said, because I'm dividing by both, log base a of 5. So what do we got? Let's sub it out. This is q minus the 2 is r minus the 5 is p. So it's q minus r minus p. And that's how you do that. Hey, this is a lot of rules, I know, but I definitely won't have a 28-minute video. Good luck to you all out there. This is Mr. Kelly in K-Town. Remember, it's nice to be important, but it's more important to be nice. See you.